Hello and welcome everyone. My name is Syed Wahaj and today we are going to deal with year 13th of A2 level physics. So welcome everybody. At STEM Education, we try to bring to you the best explanation to the physics and all the science courses which are carried under the IGCSE syllabus. So the topic that we are going to start today, the first chapter in the 13th year is energy in collision. Energy in collision, right? Energy in collision. Okay, so here we can see that this is the book that we are going to refer to. It is a specific book for the IGCSE syllabus, and the name of the topic is energy in collision. It is the 5A topic in the book. So let's get started with the topic and let's see what it's all about. So the thing that we are going to study today is all about energy. The first idea that we are going to deal with today is that of energy, right? So all of you must have heard about the idea of energy. What is energy? So if somebody has energy, they have the capacity to do a lot of things. For example, a person who has a lot of energy can run longer distances. A person with a lot of energy can fight and win. So energy is all about the capacity to do something. If we delve deep into the idea of energy, if we are going to delve deep into the idea of energy, so we don't really have a specific definition of the word energy. What is energy? Let's have an understanding. Let's discuss another concept which we use in day-to-day life. It is the concept of money. All of us know what is money. What is money? If I'm teaching you, somebody is paying me. If you are going to buy a laptop for yourself, you have to pay someone for the laptop. If you are going to eat at a restaurant, then you are going to pay for something. So money is basically something which has to be transferred from body A to body B. It is something which is transferred, something of worth, which is being transferred from body A to body B. Until and unless we are not transferring the amount of money from one body to another body, from one person to another person, nothing really happens in our world. So in terms of money, we can say that money is currency notes, dollars, yuan, and euro. These are the different currencies. Also, let's say I somehow transfer some amount of property to you. I give you a vehicle like a Ferrari car. So if I'm going to give you something of worth, then we can say that some amount of money is transferred from me to you. So if we are going to ask this question, what is money? What is money? Anything of worth is money. Let's take another example. Let's take an example of a village. So here we have a village. And in this village, many people are living in this village. There is a person A, and there is a person B, and there is a person C, D, E, F. There are 6 people living in this village. So what does A do? A gives $5 to B and asks B to teach his child. So B takes $5 as fees and he teaches child of Mr. A, right? Then what happens? B goes to C and gives $5 to C and asks C to clean his house. So what does C do? C takes $5 from B and cleans the house of Mr. B. Now C goes to D, it gives $5 for something, then D to E $5, E to F $5, and F to A $5. Okay. So what happens? The money is being transferred from one person to another, then another to another. It keeps on happening like that, and things keep on working, the village keeps operating the way it wants to operate. So what is money? Money is something which is transferred from one body to another body. And while money is being transferred, some activity happens. So that is the idea of energy basically. Energy is a currency. Energy is a currency that is transferred from one body to another when anything happens. So we can write the definition of energy. Energy is the currency of universe. Energy is the currency of universe. Right? Energy is the currency of universe. And we say that when we are talking about the money, we were talking about dollars, how many dollars are being transferred from one man to another. Here, the unit of energy is joule. Unit of energy is joule. Well, there are many units of energies, like energy like calorie, like joule, and there are other units as well. But in SI system of units, in international system of units, SI system of units, joule is the unit of energy. So when we study about what is happening around, we say that for any activity, for anything that is happening, some transfer of energy is associated while any activity happens in this world. Okay, so that is why we say that energy is the currency of universe. Good. Now let us start with the idea of modes of transfer of energy. Modes of energy transfer. Modes of energy transfer. Good. So how do you transfer energy from one body to another? Now, what is energy? Energy is basically a currency, right? So how do you transfer currency from one body to another? In today's world, we can give check, we can pay through internet banking, we can give bonds, we can use dollar bills. So there are different methods, there are different ways in which we can transfer energy from, we can transfer money from one person to another. We can use bank accounts, we can use notes. There are lots of ways in which we can transfer money from one body to another. Similarly, energy can also be transferred from one body to another body in basically two ways. So there are basically two ways of modes of transfer of energy. Okay. So the first mode of energy transfer is work. Is work. And the second mode of energy transfer is heat. So work and heat. These are the two modes of energy transfer. If I want to lose some energy, I want to give energy to something, we can either heat it up or we can do some work. Now let us have an idea about these two things in a little bit of detail. How does energy gets transferred through the work? For this, we need to apply force. We need to apply some force, right? So if we are going to apply any force on something, is it true that energy starts getting transferred immediately? No, it doesn't happen like that. Energy doesn't start getting transferred immediately after application of force. There's another condition as well. Let's see what that condition is. The other condition is, if we are going to apply some force, and under the influence of that force, under the influence of that force, under the influence of that force, the object experiencing force starts moving. The object experiencing the force starts to move along the line of force. Along the line of force. Move the line of force. Okay. So let's take an example. This is a ground, and on this ground there is a block like this, and somebody is applying force on this block of 5 Newton, and under the influence of this 5 Newton force, this block starts moving. This block starts moving. So this block was originally at this location. This block was originally at this location, and finally the block has arrived at this location. This is the displacement, delta R. Delta R is the displacement of the block from initial point A to final point B. So this displacement of block is in the direction of force. So if let's So this block, which is being pushed with a force of 5 Newton, and under the influence of this 5 Newton force, it undergoes a displacement of 2 meters in the direction of force. The direction in which the force is being applied, the object is getting transferred in that same direction. Now, if somebody is asking me this question, how much energy is being transferred to this block by the person who was applying this force? This man, the name of this man is X, and the man X is pushing this block towards right with a force of 5 Newton. So what happens here? We can say that the force which was acting, which was equal to 5 Newton, would get multiplied to the displacement. So the work done is equal to force into displacement in the direction of force, in the direction of force. Okay, so what happens? We have a force of 5 Newton, and this gets multiplied by 2 meters, which gives 10 Newton meter, which is equal to 10 Joule. Okay. So after pushing this block for 2 meters with a force of 5 Newton, Mr. X is poorer by 10 joules, and the block is richer by 10 joules. It means 10 joule of energy is extracted from Mr. X and is supplied to the block. How much joule? 10 joule. Okay. So if somebody is pushing something and that something is moving along the direction in which it is getting pushed, then we multiply the force and the distance between the initial and the final point, the displacement, which undergoes in the direction of force. And when we multiply it, we get this much amount of energy is being transferred from the body who's pushing to the body which is being pushed. So this is the work. This is the way energy gets transferred from one body to another. So you want to lose some energy, go push something. You want to lose energy, do something. Just go and take the barbells and start doing exercise and something like that. So once you start moving something, once you start pushing something, you start losing energy. You need to have some food. So if you do a lot of work, if you push a lot of things, if you pull a lot of things, then you keep losing energy constantly. And the mode in which you are losing the energy, that mode of energy loss is called work, right? Now, the other mode of transfer of energy, the other mode of transfer of energy is called heat. So let's ask this question, what is heat? Let's say this is a body, and this body is at 100 degrees Celsius. It's a boiling water. Let's say it's a boiling water. It's a boiling water. A boiling water. Okay. So what happens when we keep this boiling water, when we keep this boiling water in an external environment where the temperature is, let's say, 30 degrees Celsius. The ambient temperature is 30 degrees Celsius, and the temperature of boiling water is 100 degrees Celsius. What would happen? We can see that the energy would start getting released, from this boiling water, and the surrounding starts receiving the amount of energy which is being lost by this boiling water. So this boiling water constantly keeps losing energy, and the environment constantly keeps getting the energy. And why is it happening? Because there is a temperature difference. The temperature of the ambient temperature is 30 degrees Celsius, and the temperature of boiling water is 100 degrees Celsius. So which one is more? This is the hotter body, this is the cooler body. So what happens when a hotter body is brought in contact with a cooler body? When a hotter body is brought in contact with a cooler body, the hotter body starts losing energy, and the cooler body starts gaining energy. So the amount of energy which is being transferred from a hotter body to a cooler body, this energy transfer is called heat. So let's ask this question, what is heat? Heat is the energy. Heat is the energy which is being transferred, from a hotter body to a cooler body, when they are brought in contact with each other. So we have studied what is energy. Energy is the currency of universe, and how do we transfer energy? How energy is transferred from one body to another? The energy is transferred from one body to another in two modes. One of them is work, another one is heat. Work is when we push something, and when we push something, we start losing energy, and the thing which is being pushed starts getting energy. So this kind of energy transfer is called work. And when we bring a hotter body in contact with a colder body, it starts getting transferred. The energy starts getting transferred from a hotter body into the cooler body. Such kind of energy transfer is called heat. So these are the two ways of energy transfer. Now let's see that we have two modes of energy transfer, but under the current purview of our study, we are not going to study much about the heat. Heat is not something that we are going to deal with right now. What we are going to deal with is work, and how energy is being transferred through the mode of work. Now let's discuss a little bit more about work. What is work? What is it? Now work is of two types. Work is of two types. There is a positive work, and then there is a negative work. Okay. Now let's ask, what is a positive work? When do we say that the work is being done as positive? Okay. Let's write down another important thing in the side. A side note, it's kind of very important thing to understand. Work is done by a force. Okay, let me give you an example. What I've written, let me try to explain it a little bit. We have this block here. Name of the block is A. Okay, there's a man standing adjacent to the block. This is the man. Name of the man is X. So there are two things over here. There's a man, name of the man is X, and there's a block, name of the block is A, right? Mr. X is pushing this block rightwards. Okay? Mr. X is pushing this block rightwards. So this red arrow is the force experienced by block A and is applied by man X. So let's try to give it a name. Let's call it FAX. FAX. Why have we given it a name of FAX? Because the force is being applied on A by X. Got it? So this force, who is experiencing this force? A. And who is applying this force? X. That is why we call it FAX. Right? Now, let's talk about a person whose name was Newton. So Newton was a person who said that if somebody applies force on something, that something is going to apply this equal and opposite force backwards on the body which is pushing it. Okay? So this is a pen and we are trying to hit it. We are trying to hit this pen. So we are hitting it like this. Okay? So when we are hitting this pen like this, we are pushing this pen towards that direction. But simultaneously, this pen applies force on my finger backwards. That's why I feel like I'm hurt when I'm trying to hit it. But when I hit the pen hits me back. So that is the action and the reaction. So if Mr. X is trying to push block A towards right, the block A is again going to push Mr. A towards left. Okay, let's use the different pen. Let's use this. That will be better. So this is again a force, and this force F is being applied on X by Mr. A, right? So there are two forces here. One force which is being applied on A and another force which is being applied on X. Who's applying force on A? Mr. X. And who's applying force on X? Mr. A. These two are actually in pairs. Both these forces are equal in magnitude, but they are opposite in direction. Right. So that's the current situation that we are having. Now, if this block A moves certain distance, let's call it 2 meters. Let's call it 2 meters. And let's assume that the force which is being applied is 5 Newton. Okay. So 5 Newton force is being experienced by the block, and this block moves 2 meters towards the right. So what is the work done by the force FAX? Work done by the force FAX is equals to FAX multiplied by 2, which equals 5 into 2. And it is 10 joule, which is positive. Why? Because the force and displacement are in the same direction. Force and displacement are in the same direction. Okay. So the force FAX and the displacement of 2 meters, okay, both these things are in the same direction. That's why the work done by the force is positive. Let's try to write another thing. What is the work done by force XA? So this force, okay, this force, it is going to be Fxa multiplied by 2, which will be equal to negative 5 into 2 equals negative 10 joule. That is a negative work. Why negative? Because the force and the displacement are opposite to each other. To each other. Right? Got it? So when we are talking about work, we have a positive work and a negative work done by a force. Positive work done by a force, and the negative work done by a force. Work is always done by a force. So when positive work is done by a force, the force and displacement are having the same direction. The force and displacement both are going to move in the same direction. But if the work done is negative, then the force and displacement are directed opposite to each other. So what is a positive work? In positive work, the force and displacement have same direction. Right? The force and displacement both are having the same direction when the work is done positive. And he who applies this force, loses energy, and he who experiences this force gains energy. Right? Let's see the example again. This is the ground, this is the block, and this is the man. This is the man, and this man is applying force. This is a force, F-A-X, and displacement is along the same direction. So F-A-X is, let's say, 5 Newton. The displacement is 2 meters. The work done is 5 into 2 plus 20. So the F-A-X force does positive work. F-A-X does how much? Plus 20 force, plus 20 joule of work. What does it mean? It means that this man X is losing 20 joule and the block A is gaining 20 joule. Okay? Why? Because when the work done so this force FAX is doing a positive 20 joule of work. So when the force is doing positive work, the person who's applying this force loses energy, and the person who's experiencing this force gains 20 joules of energy. So 20 joules of energy comes out of X and goes into A, 20 joules. Why? Because the force is doing a positive work, right? Similarly, if this man, Mr. X, is constantly being pushed backwards. This man is constantly being pushed backwards. Okay? Why? Because A is pushing Mr. X backwards. F X A. What is this force? This is the force which block is applying on Mr. X. Why? Because we know Newton's third law, every action has equal and opposite reaction. So Mr. X is constantly being pushed backwards by the block. But when he tries to push this block forward, he also moves ahead 2 meters. He moves 2 meters in this direction. He keeps pushing the block, right? He keeps pushing the block, and when he keeps pushing the block, he moves along with the block forward. So this is the black block here, earlier, and the block remains at this location. So he keeps pushing it. So the displacement of 2 meters is in the right direction, and the force X is in the backwards direction. Okay, so what is the force Fxa? What is the value of Fxa? The value of Fxa is going to be 5 Newton, right? 5 Newton. Why 5 Newton? We know Newton's third law. It says that every action has equal and opposite reactions. So if X is pushing A with 5 Newtons, A is also pushing X with 5 Newtons backwards. So this is 5 Newton and this is 2 meters. What is the work done? Now the force is towards the left and the displacement is towards the right. So how much work is being done? How much work is being done? It is negative of 5 into 2, which means negative 10 joules. Okay, so what does it mean? It means that he who is applying the force is not losing the energy, he is gaining the energy. Okay, so when the work done is negative, when the work done by a force is negative. So when the work done by a force is negative, then force and displacement are opposite to each other, right? When the work done by a force is negative, then the force and displacement are opposite to each other. Okay, we get it? And he who applies this force, gains energy, right? Means who is applying this force? Fxa. Who is applying this force? A is applying this force. So when A is applying this force and the work done by the force is negative, he who applies force is gaining the energy. Okay, let's do a little bit of recapitulation. So that this idea sinks in your mind. This is a ground. On this ground, we have a block. Name of the block is A. And this block A is being pushed by a man. Name of the man is X. So the man X is pushing the block A rightwards with a force of Fxa, right? Or Fax, force experienced by A and applied by X. Simultaneously, due to action-reaction law of Newton, the force will be experienced by X due to A. So this is the situation which is happening over here. We can understand the phenomena in two ways. In two ways. Let's study the same phenomena in two ways. The first thing we can do it's delta R. Delta R is the displacement. Okay? Delta R is the displacement, right? So we can study. So there's a block A which is being pushed by man X towards the right with a force of FAX. This force is being applied on the block by man, and simultaneously the block is pushing the man backwards with a force of FXA. So these are two forces and these are two things. We can study the same phenomena while focusing on, we can either focus on, let's say we can focus on the block, or we can focus on the man. Okay, so if we are focusing on the block, so the block is experiencing force FAX and the man is experiencing the force FXA. So these are the two forces. One is FAX and the another one is FXA, right? Now here, when we are focusing on the block A, the work done is going to be due to force FAX. Why? Because we are focusing on the block. Okay, we are focusing on the block and we are asking the question, what force is acting on the block A? So we say that FXA is acting. Now this force and this displacement are having the same direction. We can have FAX multiplied by delta R, and that's going to be positive. When it means positive, that means the force is doing a positive work, which means the person who's applying this force is losing energy. One who applies this force loses energy, right? The one who applies this force loses energy. And who is applying this force? The man. So the man is losing energy here. Okay. If we are going to focus on the man X, the force which we are going to consider here, is FXA. This is the force we are going to consider here. Why? Because we are going to talk about the man. What kind of force is being acting on the man? So when we try to work out the force, the work which is done by the force FXA, work done by the force FXA. So this force is backwards and the displacement is forward. That's going to be a negative work, right? So work done by the force FXA is negative, right? Why? Because the force and displacement are opposite to each other. So if these two forces are opposite to each other, what will happen? We are going to get a negative work. Good. So if here we have a negative work, it means that the person who's applying this force, is gaining energy, right? Who is applying this force? The block. The block is actually applying this force. So when the block is applying this force, block is actually gaining some energy. Got it? So here we have the idea of negative work. Okay. So the same phenomena here. Here, A is gaining energy. A is gaining energy. Right? And here, X is losing energy. Both the things are same. If X is losing energy, then obviously A would be gaining the energy. And if A is gaining the energy, obviously X would be losing the energy. So the same phenomena can be viewed in two ways. The same phenomena of a man pushing a block can be viewed in two ways. Either we can focus on the block or we can focus on the man. If we are focusing on the block, we are going to talk about the energy work done which is due to this force. And when we are focusing on the man, we are going to talk about the energy work which is being done with this force. This force does negative work. This force does negative work. So the one who is applying this force gains energy, that is block gains the energy. Okay. This force does positive work. So the person who is applying this force loses energy. So X loses energy. So when we are talking here, we are saying that X is losing energy. When we are talking here, we are saying that A is gaining the energy. Both the things are same. So if A is gaining the energy, X is losing the energy. If X is losing the energy, then A is gaining the energy. Both the things are same. But it's just that what we are focusing upon. So we can talk about negative and positive words. So I think we should try to write it down, and we have to have a very solid and a good idea about how work is taken to be negative or positive, because this idea is going to rule throughout this chapter, and this chapter is totally based on the idea of how much work is done by what thing. And when we are talking about collisions, we are going to have an understanding about the different kind of works, and positive and negative work. It's a very important thing to understand. So thank you so much for today. We have understood in this chapter what is work, how much energy is being transferred when a work is done by something, and these are the different topics we have covered today. In the next topic, we would be dealing with the amount of energy which is stored, like kinetic energy and potential energy. We have talked about the mode of transfer of energy today. Tomorrow, in the next class, we are going to talk about the energy which is being stored in the body, and why and how much energy is being stored in the body, and what's the reason for all of that. So thank you so much for today's class. I hope you have understood well the concepts that we have discussed today. And okay, goodbye. And I welcome you back. I would like you to come again to the STEM education platform, and I hope you would be able to learn physics in a way which is way more clearer and way more easy to understand, and it will help you do a lot of questions. Thank you so much.